Hi guys. There was an example that we didn't get to on Friday that I just wanted to make sure that you guys saw. There are some situations with integration by parts where you have to do the process twice. Here's an example of one like that. So if you see, you should make u x squared, and then du is 2x. dv, can you see that? Yep. Will be cosine of x dx, and then v would be the integral of this. So think of like who has this as its derivative, so that's sine. And then like this gets rewritten as x squared sine of x minus the integral of this times this. So I'm going to put the 2 on the outside. So this is still something that you would use integration by parts to solve. So we're going to let u now be x. Maybe I should use, I don't have another color. Du is dx. dv is sine of x dx. And v would be negative, oops, that's not right. Negative cosine of x. All right, so now we would rewrite this again as x squared sine of x minus 2, and then uv minus the integral of v du. So this negative, I'm going to make that a plus. All right, so now this becomes x squared sine of x minus, oh, maybe I should, plus 2x cosine of x. And let's just do this quickly off to the side. So what's the integral of cosine? So who has cosine as its derivative, and that's sine. So then this is going to distribute to that too. So it'll be minus 2 sine of x, and then you always are going to need the plus c. So that's the long way to do that. There's a shortcut though. It's called tabular integration, and some kids last year used tabular all the time. But in general, tabular integration, this shortcut is useful when this is gonna take 2 steps. So that often happens when this is a power higher than 1, and this is either sine or cosine or something with e to the x. I'm gonna try to move this thing. I have a little tripod. Okay. So let me show you the integration or the tabular way, the shortcut. So you make a little table. You put the thing here that's your u, the thing that you can derive a bunch of times and you end up with 0. So won't that be x squared? So then we're just going to continually take the derivative of this until we get 0. Then the other thing that you put here is the other guy. So here, cosine of x. Now this is the thing that kids screw up a lot. You do not derive this, you integrate this. Kind of like we did, we did over here. How we put this here, we derived it. We put this here, we integrated it. Okay. This is so fancy. All right, so now the integral of this would be sine of x. And then the integral of that would be negative cosine of x. And the integral of that would be negative sine of x. So to just make sure that you did it right, just go take the derivative backwards and make sure that's right. All right, so the derivative of negative sine, that's really negative cosine. The derivative of negative cosine, that's really sine. The derivative of sine is really cosine, so you're good. All right, so now here's the shortcut part. Your terms of the answer will be these 2 multiplied, and then these 2 multiplied times, and then these 2 multiplied, the terms written out. So the first one, you keep the sign of it. You don't change the sign of it. This one, you change the sign of it. And this one, you don't change the sign of it. So you just alternate. It starts, you keep the sign, you change the sign, you keep the sign. So I'm just writing plus minus plus because I'm kind of multiplying this by a positive 1, multiplying this by a negative 1, multiplying this by a positive 1. All right, so then here it ends up being x squared sine of x and minus 2x cosine of x minus 2 sine of x. You always need the plus c. And if you see, can you see them both? Those answers, are the same. This just takes a little bit less work. Like once you get used to this, it's like super quick. But it's really only useful when this power is higher than 1. And this is something that like you can integrate over and over again. Like e to the x stuff, cosine or sine stuff, you can integrate over and over again. Okay, hopefully that helps. Message me with questions.